Part C, the reflection of sound waves or an echo can be used to measure distance. The length of a room can be found using a device which emits a pulse of sound here and times how long it takes to return. This is then converted to a distance and displayed on the screen of the device. The displayed distance is the length of the room. And so you can see there that the length of the room there, 4.08 metres, is from there to there. The diagram shows such a device and the distance displayed for a particular room. If the speed of sound is 340 metres per second, how long does it take the sound to travel from the device to the opposite wall? You are advised to show clearly how you get your answer. Now, this is almost a bit of a trick question because they've mentioned the word reflected or echo. You almost think you have to divide a time by 2 or a distance by 2, but the distance they've actually given you, and they've written that, they've said 4.08 metres is the length of the room. So you're just doing speed is equal to distance over time. Rearrange your equation, so time is going to be distance over speed. And that's going to give you 4.08 metres divided by the speed, which is 340. And so the answer then comes out to be 0.012 seconds. And given that there's 4 marks here and no unit in here, then there's definitely a unit mark. And those are what your marks are going on. Your seconds, your answer, your calculation, and your rearrangement of your equation. When the user of the device presses a button, the sound emitted by the device is a pulse, i.e. a short burst of sound followed by silence. Explain why a continuous sound wouldn't work. So we want this short burst of sound followed by a silence. So you have to think of a good reason why. Now obviously if it was a continuous sound, the device would have lots of trouble picking up when the sound it sent out to test the length of the room returned to it. And so you need to have something like that as your answer. So something like the echo would be continuous, there'd be no gap in the sound. So if you had a continuous sound coming out of your device, you'd have a continuous echo. There'd be no gap. And the device wouldn't be able to detect. I'm going to use the word distinct echo because what it would have coming back to it would just be a continuous sound. Now, there's 2 marks there. They're really, what they're looking for is this idea here about the distinct echo, and they're really going to award 2 marks for that. That kind of question, we can't teach you that kind of question. You have to use your common sense and try and apply your knowledge, and you just have to do the best you can. Go through the question, underline words you think are important that you would need to explain in your answer, and try and pick up the 2 marks if you can. The drawing shows sound waves approaching an open doorway. By drawing the shape of the sound waves after they pass through the doorway, explain how the person standing at point X can hear the sound. What is this process called? So this process is called diffraction. And I know that when waves are diffracted, they're spreading out into areas that wouldn't normally be detected. But I also know that their wavelength doesn't change. So I'm just going to put my ruler down and measure. The wavelength there is about 12 millimeters. So I'm going to make sure that my waves that come through here have a wavelength of about 12 millimeters. And so I'm actually going to start 12 millimeters beyond my barrier just to make sure that I'm going to put at least 2 of them in here, and I'm going to put them in as circles. I might put one more, I don't know if I'll fit it in, but we'll give it a wee go. So what you're going to try and do is make sure that your wavelength's nice and circular here, and then roughly that distance apart go through here. So this one's going to go through X. It's not too circular looking, but and then one more. And there's my shape there. And so you can see here, if the wavelengths had just gone through the way they are, they would just be going along like that there, and none of them would have reached X. So diffraction, so you're going to use the word diffraction, and you could also say something about the fact that the waves are spread out. And that would definitely get you your 2 marks. Around behind barrier. But really you'll pick up your 2 marks for saying the waves are diffracted and your diagram.